1. What specific problem does your paper seek to address regarding the effectiveness of chain of thought CoT prompting techniques in large language models?
The paper addresses the effectiveness of chain of thought CoT prompting techniques in large language models, LLMs, by systematically evaluating where CoT is beneficial and where it may be ineffective or even detrimental. It highlights that CoT significantly aids in tasks requiring mathematical, logical, or algorithmic reasoning, while showing limited benefits in non-symbolic reasoning tasks, such as common-sense reasoning. The research reveals that the performance gains from CoT are primarily attributed to its ability to assist in the execution step of reasoning, particularly in symbolic tasks, but it falls short compared to tool-augmented methods. Additionally, the paper emphasizes the need to move beyond CoT to more sophisticated approaches for reasoning tasks that do not involve symbolic manipulation. Overall, the work aims to clarify the contexts in which CoT is effective and to identify more efficient prompting strategies for various reasoning tasks.
2. Can you break down the proposed methods step by step, detailing how you conducted your systematic meta-analysis and experiments on the 20 datasets and 14 contemporary LLMs?
To conduct our systematic meta-analysis, we first filtered a total of 4,642 papers from ICLR 2024, ECL 2024, and NAACL 2024, identifying 516 papers that mentioned CoT or similar terms. We then manually extracted results from papers that compared CoT prompting with direct answering, ensuring that both methods were evaluated on the same model and dataset. This process yielded 1,218 experimental comparisons across 110 papers, which we categorized into 14 reasoning categories based on task descriptions. For our experiments, we selected 20 datasets and 14 contemporary LLMs, focusing on instruction-tuned models and excluding non-English or math-specific models. We implemented both zero-shot and few-shot prompting strategies, tailoring our answer extraction methods for each dataset to ensure accurate performance evaluation.
3. Provide a specific example illustrating the inner workings of your method. How did you set up a CoT prompt versus a direct answer prompt for a particular dataset?
In our experiments, we set up a chain of thought CoT prompt and a direct answer prompt for the MMLU dataset, which includes a variety of reasoning tasks. For the CoT prompt, we used a strategy that encouraged the model to think step by step, allowing it to generate a longer sequence of reasoning that included intermediate steps leading to the final answer. This was denoted as I_ in our methodology. Conversely, for the direct answer prompt, we instructed the model to immediately generate the answer, which we denoted as I_DA. This direct answer prompt was structured to concatenate the question with a description of the strategy, ensuring that the model would focus on providing a concise answer without elaboration. We tailored the answer extraction function to ensure that it could effectively parse the outputs from both prompting strategies, allowing for a fair comparison of their performance across the dataset.
4. What are the primary theoretical or practical benefits of your proposed method in comparison to traditional direct answering methods?
The primary theoretical benefit of the chain of thought CoT method compared to traditional direct answering methods lies in its ability to enhance the execution step of reasoning tasks, particularly in symbolic and mathematical contexts. CoT allows language models to generate executable formal solution plans and perform symbolic manipulation more effectively than direct answering, leading to substantial performance improvements on tasks that require complex reasoning. Practically, our findings indicate that CoT significantly benefits problems involving mathematical, logical, or algorithmic reasoning, with average performance gains of 14.2% for symbolic reasoning tasks. However, it is important to note that CoT's utility is limited in non-symbolic reasoning tasks, where it may not provide any advantage or could even hinder performance. Thus, while CoT can improve reasoning capabilities in specific domains, it is often unnecessary for many problems where more efficient prompting strategies exist.
5. Describe the validation process you implemented for your method. What metrics did you use to determine the performance of CoT versus direct answering, and how did you ensure robustness in your evaluations?
To validate our method, we conducted a systematic meta-analysis of recent literature comparing the performance of chain of thought, CoT, prompting against direct answering, DA, across various tasks. We filtered 516 papers to extract key results where CoT and DA were compared on the same model and dataset, resulting in 1,218 experimental comparisons across 110 papers covering 264 datasets. We categorized tasks into 14 categories based on their reasoning requirements and tracked the average performance metrics, specifically focusing on the CoT delta, the difference in performance between CoT and DA. Additionally, we performed experiments on 20 datasets using 14 contemporary LLMs in both zero-shot and few-shot settings to further assess performance. To ensure robustness, we excluded multimodal models and those using external tools, and we applied a Bonferroni correction for multiple comparisons, setting a stringent p-value threshold to determine the significance of improvements from CoT.
6. Discuss the limitations identified in your work. In what scenarios might CoT fail to provide a performance boost, and how could these limitations affect future research on reasoning in language models?
In our work, we identified several limitations regarding the effectiveness of chain of thought, CoT prompting. Primarily, CoT fails to provide a performance boost in non-symbolic reasoning tasks, such as those involving common sense reasoning or language understanding, where it often yields little to no improvement or can even hinder performance. This limitation suggests that CoT is most beneficial for tasks requiring mathematical, logical, or algorithmic reasoning, as evidenced by our findings that the majority of performance gains are attributed to questions containing symbolic elements, particularly those with equations. Additionally, we noted that CoT's utility is often overshadowed by more powerful tools, such as external symbolic solvers, which outperform CoT in execution tasks. These limitations highlight the need for future research to explore more sophisticated approaches beyond prompt-based CoT, potentially focusing on integrating search strategies or developing models specifically fine-tuned for reasoning tasks that do not rely on symbolic manipulation.